All right. So as I was saying, yeah, previously हम लोग quantum physics की working कर रहे थे. So regarding the working of quantum physics, we concluded. So the first component of quantum physics was photoelectric effect. We were done with this working in the previous class. So ये हो गया था. ठीक है. अब आज वाली क्लास के अंदर this is the second component of quantum physics, which falls under the heading of energy levels in atoms, also called spectral lines. So यार ये वाला काफी छोटा टॉपिक है और होपफुली आज ही कंक्लूड हो जाएगा. So we will start with this topic and probably we'll conclude this topic today as well because ये start और end एक ही क्लास की थ्योरी है तो ये आज ही हो जाएगा. और फिर इसके बाद इसका थर्ड वाला सब टॉपिक है which is under the heading of band theory. ये फिर next class में करा दूंगा. Band theory is also a one class lecture. So ये hopefully अगली क्लास में conclude हो जाएगा. और energy level is also a one class lecture. ये आज conclude करा देता हूँ. ठीक है, so we'll start with the heading energy levels in atoms. So I'll change the page, नई वाली next slide पे चला जाता हूँ और वहां पे working start कर लेते हैं. सही है. So आज हम लोग energy levels कर लेंगे और फिर next वाली क्लास के अंदर इंशाल्लाह band theory conclude हो जाएगा. Okay. So the main working, which comes under the heading of energy levels in an atom. So essentially, इसका beginning वाला portion जो है ना, this is largely chemistry related. और I guess when I'll read it through ना, तो आपको AS chemistry से याद भी आ जाएगा. So let me just quickly go through with the wordings. आप मेरे साथ साथ follow कर लो. फिर जो calculations वाला part होगा ना, उस पे move कर जाना. तो statements पहले देख लेना. Okay, so the first point. It is believed that electrons can orbit only in certain allowed discrete orbits. These orbits are called energy levels. Okay, so electrons can orbit only in certain allowed discrete orbits. And these orbits, in chemistry, they are referred to by the term energy levels. The electron normally occupies the lowest energy level available and is said to be in its ground state. सही, ये term तुम लोगों ने chemistry में किया हुआ है. So when the electron occupies the lowest energy level available, then this electron is said to be in its ground state, where it has the least amount of energy. In this manner, the electron is also said to be in its most stable state. All right. Now the third point. If this electron absorbs sufficient energy, which could be due to the bombardment of the incoming photon, then this electron may be boosted to one of its many other higher energy levels. So ये chem में करते थे आप लोग. And if this transition happens, then the electron is said to be in an excited state. आपने ये वाला term भी chem में किया था. And the energy absorbed by this electron to jump from the ground state to a higher energy level is known as excitation energy. Okay, so most of this wording if you recall, was done in AS chemistry, that electron generally prefers to occupy the lowest energy level available. And in that case, electron is said to be in its ground state. And if sufficient energy is provided to this electron, then this electron may jump, or this electron may transit from its ground state to any one of the higher energy levels available. And if that happens, the electron is said to be in an excited state, and the energy which is provided to it is termed as excitation energy. Okay, moving on further. So from the next line, sometimes an electron may receive sufficient energy which enables it to escape completely from the attractive forces of the nucleus. When this occurs, the atom is said to be ionized, and this energy is termed as ionization energy. Okay, so basically, the concept of that electrons exist in discrete energy levels was given in AS chemistry. The fact that electron normally occupies the lowest energy available, and in that case, the electron is said to be in its ground state. And also the fact that if this electron is provided with sufficient energy, then the electron can jump or transit from its ground state to any one of the higher energy levels. And the energy provided is termed as excitation energy. And sometimes an electron may receive sufficient energy which enables it to completely overcome the attractive forces of the nucleus. And if that happens, then the electron gets a chance to be a free electron. The atom is then said to be ionized, and this energy is termed as ionization energy. Acha, before I continue, can you go up a bit? I'm copying the notes, but I'll take a picture. Yeah, you don't need to, Marzia. मैं lecture बेटा upload कर दूंगा Google Classroom में right after your class ends. So I think पूरा as it is proper form में lecture होगा. So I guess वहां से कर लेना. Don't waste your time copying right now. I don't think it's going to help as such. ठीक है मर्जिया? All right, यार. Now, physics का concept इसमें कहाँ से आएगा? So, अब जो आगे की working है ना, everything which I'm going to read from this point onwards, ठीक है, I'm making this partition. तो जो top वाली information थी ना, वो basically chemistry based information थी. And the wordings which I'll go through right now, इसमें आपका physics की involvement आ जाएगी. कैसे वो देख लेते हैं. So the energy levels for an atom can be constructed as discrete horizontal lines which are shown below. So chemistry में तुम लोगों ने थ्योरी तो पढ़ी थी. फिजिक्स में हम ये डिस्कस करते हैं कि हम एनर्जी लेवल्स की कंस्ट्रक्शन कैसे करेंगे और हम कैलकुलेशंस कैसे करेंगे. So regarding the construction, the wording says that the energy levels for an atom can be constructed as discrete horizontal lines shown below. तो मैंने नीचे बनाई हुई है. अच्छा, further आगे. The energy content of these energy levels is measured either in joules or in electron volt, and a standard diagrammatic representation for these energy levels is given below. ठीक है, तो physics के point of view से, from the physics standpoint, the energy levels are shown as discrete horizontal lines, and the energy content of these energy levels can be measured either in units of joules or it can be measured in units of electron volt. So a standard way of representing these energy levels diagrammatically is given as follows. So the bottommost line, जो सबसे नीचे बनी हुई है, इसको जनरली आप लोग रेफर करते हो एज योर ग्राउंड स्टेट। फिर उसके ऊपर जो आपके पास नेक्स्ट वाली हॉरिजॉन्टल लाइन है, दैट इज referred to by the term first excitation state. Then the next one, second excitation state, and so on and so forth. So I just label a few of them. Okay, so the bottommost line, which has the least amount of energy, is referred to as the ground state, and all the other horizontal lines are referred to by the terms first excitation state, second excitation state, so on and so forth. Now, the energy possessed by each of these energy levels, which can be either mentioned as joules or it can be mentioned in units of electron volt. So usually physics के अंदर the energy values are given as follows. So ground state के लिए the energy will be given like the way I am representing. You don't need to learn any of these numbers because based on every individual atom, the energy levels will differ. The energy content will also differ. तो examiners ये करते हैं कि आपको ये पूरा diagram with the energy levels and everything पूरा बनाकर दे देते हैं and it is expected कि आपको इन numbers को use करके calculations करनी है. ठीक है, so these values which I'm writing with the green marker are not to be remembered, but this is how generally a standard diagrammatic version representing the energy levels and also representing the energy contents is provided in the exams for you. तो मैं एक दो values जरा लिख लूं and then I'll move on to the calculation part. So guys, एक second रुकना, मैं जरा numbers को fill up कर लूं. So these values can be given to you either in electron volt or they can be given to you in joules, like the way they are mentioned. ठीक है, the question does arise जो रिहा ने पूछा है. So I was about to answer that question. या रिहा इसको everyone पे set करके दोबारा message please लिख लो. Because that was the question which I was about to address. So since आपने पूछ लिया है ना, just rewrite that question for everyone ताकि बाकी लोग भी follow कर लें बेटा. और फिर मैं answer दे देता हूँ. ठीक है, so the question that Riha is asking, how come we are writing down these energy values as negative? And so that kind of does require explanation. So I was expecting कि आप इसे बोलना है ये question. तो मैंने उसकी justification के लिए question की wordings को already यहाँ पे लिखा हुआ था. Yeah, so why are these energies represented with a negative sign? See, so the concept basically arises. अच्छा, उमर ने लिखा है energy is being lost. I think थोड़ी wording को appropriate कर देता हूँ. The concept arises, Riha, from the fact that remember in gravitation, जब हम लोग Earth की बात करते थे, and imagine if there is a satellite orbiting the Earth. Remember, we always used to say that the natural tendency of the satellite is to be always pulled inwards, that is towards the center of the Earth. And since the natural tendency of the satellite is to fall inwards, तो gravitation में हम कहते थे work is done by the gravitational field and the work done by the gravitational field used to bring about a loss in energy. And that loss in energy, if you recall, in gravitation, it was denoted by the placement of a negative sign, which is why हमारे gravitation potential की value negative होती थी, if you remember from the first term working. So बिल्कुल same context को अगर आप न्यूक्लियस के लिए अप्लाई करते हो और अगर आप ऑर्बिटल इलेक्ट्रॉन्स के लिए अप्लाई करते हो, just like a satellite has a natural tendency to fall towards the earth, बिल्कुल वैसे ही electron has a natural tendency to fall towards the nucleus. So in gravitation, if we used to say work is done by the gravitational field, so in case of electron, we should use the term work is done by the electric field. And just like in gravitation, work done by the field used to represent a loss of energy. So बिल्कुल वैसे ही, the work done by the electric field will also represent a loss in energy. And that loss, similar to gravitation, is represented by the placement of a negative sign. Okay, so the idea is obtained from the basic concept of gravitation. And since there is a similarity in terms of, sorry guys, excuse me. So since there is a similarity in terms of that out there work was done by the gravitational field, out here work is done by the electric field. So loss in energy in both cases, consequently the placement of the negative sign. Okay, so that kind of addresses that question of coming back to this working. So as I said, these energy levels will be given to you in the exams. The labeling will be similar to the labeling which I'm showing you right now. And the energy contents are also going to be given to you. Now, what kind of questions do we expect? तो अब उसकी एक judgment कर लेते हैं. So let's suppose if I were to assume that an electron is already in its ground state. Imagine this to be an electron which is already in its ground state. Let's also assume that the green colored line represents a photon of electromagnetic radiation. And if I were to assume that the incoming photon of electromagnetic radiation is going to transfer its energy to the existing electron in the ground state, thereby causing this electron to transit from its ground state to the first excitation state. So I'll show that transition with an orange colored line. My question is, if you are asked to find out what should be the wavelength of the incoming photon, which is responsible for exciting the electron such that the electron transits from its ground state and reaches the first excitation state. तो मैंने नीचे क्वेश्चन की वर्डिंग्स को इसी तरह से फ्रेम अप किया हुआ है कि कैलकुलेट द वेवलेंथ of the incoming electromagnetic radiation that can cause an electron to transit from E1 to E2. कैलकुलेशंस कैसे करनी है ना, ये काम बेसिकली फिजिक्स के अंदर हमने डिस्कस करना है. तो जो फॉर्मूला हम लोग यूज करते थे ना फोटोन की एनर्जी का in the previous topic, that was E is equal to HF, or E is equal to H times C upon lambda. In this topic, we would prefer to use the terminology delta E. Delta E इसलिए because we are dealing with two different energy levels. So अगर आप इस फॉर्मूले को अप्लाई करते हो ना, तो this is what you will get. So delta E in this case is going to be E2 minus E1. This is equal to H times C upon lambda. ठीक है, so E2 minus E1 gives you the difference in the energy level. And to work out which wavelength will cause this excitation, I've used the formula. Numbers लगाता जा रहा हूं. Mind you, these values are in electron volt. So I need to convert this into joules before I proceed. So 1 EV is equal to 1.6 times 10 to the power of minus 19 joules. मैं वर्किंग करता जा रहा हूँ, आप लोग देख लीजिएगा. So I'll get 10.2. कुछ repeat करना हो ना तो do let me know. H is Planck's constant. अली जरा आप भी और रोहिल तुम भी जरा देख लेना यार. So this working tells us which wavelength of the incoming photon can cause the excitation of the electron such that the electron transits from its ground state into its first excitation state. कितना रिजल्ट आता है ना मैं लिख लूं. हाँ यार रोहेल आप भी कर लो, otherwise Ali आप कर लेना. And while they are doing this calculation now, I think मेरी स्क्रीन पे आंसर आ गया है. 122 nanometers. Fair enough. ठीक है. Now similarly, imagine if on another occasion, अगर मैं आपको ये scenario देता कि once again there is an electron in the ground state. ठीक है, I'm just kind of repeating this calculation once again. And again, this electron is bombarded by a photon of electromagnetic radiation. And imagine this time around you are asked which wavelength will cause this electron to excite such that this electron transits from its ground state to the second excitation state. So this is how the vertical line will be shown. So बिल्कुल similar calculation आप दोबारा करोगे. मैं थोड़ा सा इसको scroll down करता हूँ. तब तक आप numbers देख लो. Which numbers would I be needing? I'm highlighting the numbers with the curly orange brackets. So I'll be dealing with these two numbers. अब कैलकुलेशन क्या बनेगी ना, तो जरा देख लीजिएगा पहले क्वेश्चन की वर्डिंग. So once again, you are expected to calculate the wavelength of the incoming electromagnetic radiation that can cause an electron to transit this time from E1 to E3. तो अगर आप वर्किंग करते हो तो आपका ये रिजल्ट बनता है. अब मैं डायरेक्ट वर्किंग कर रहा हूँ. सो डेल्टा E is equal to hc upon lambda. This time around, delta E will be written as E3 minus E1. I don't expect you to remember the numbers, but these were the numbers nonetheless. You can do the same calculation once again, and you can directly come up with the result for the wavelength. तो ये आंसर पहले मैं लिख लूं और इसके बाद स्टेटमेंट मुझे रीड करना है. So I'll move on to that. 103. Thank you. अब these answers are telling you each transition corresponds to a unique wavelength. Say, I'm sure you would agree with my statement. Each transition corresponds to a unique wavelength. So anyways, मैं डायग्राम पे पहले 103 नैनोमीटर्स को आइडेंटिफाई कर देता हूं. अब मैंने एज ए साइड नोट एक स्टेटमेंट लिखा है. मैं थोड़ा सा इसको जूम आउट कर रहा हूं ताकि आप वो साइड नोट वाला स्टेटमेंट फॉलो कर लो. So I'm basically referring to the statement which I'm highlighting right now. ये जरा मेरे साथ साथ रीड कर लो. मैं इसको जूम इन कर देता हूं. All right. The statement over here says all these vertical lines, I'm referring to the orange colored lines, all these vertical lines with arrows, all these vertical lines with arrows pointing in the upward direction represents gain of energy by an electron causing excitation. These lines are termed as absorption spectral lines. Okay, so each of the vertical line are shown with the orange colored marker, which I'm circling right now. Each of these vertical lines with arrows pointing in the upward direction represents gain of energy by an electron causing its excitation. And these vertical lines with arrows pointing in the upward direction are given a special name. They are referred to by the term absorption spectral lines. Now, I'm sure if we are calling something as absorption spectral lines, then surely there must be something referred to by the term emission spectral lines as well. It is only fair to assume if we are calling these orange colored lines by the term absorption spectral lines, then surely there needs to be some condition or some terminology which is relatable with the term emission spectral lines. So kya lagta hai? If these lines, the orange colored ones, are known as the absorption spectral lines, then what will be classified as emission spectral lines? Reverse जो एडम ने लिखा है. So यार रिवर्स का मतलब क्या बनता है ना, जो वो एडम लिख रहा है उसकी वर्डिंग्स मैंने नीचे लिखी हुई है. तो पहले स्टेटमेंट देख लो, तो रिवर्स का मतलब आई गेस आपको भी समझ में आ जाएगा. So जिसको वो एडम ने रिवर्स लिखा हुआ है ना, मैंने उसकी अप्रोप्रिएट वर्डिंग्स को यहाँ मेंशन किया हुआ है. ठीक है, तो जरा रिवर्स वाले टर्म को बेहतर तरीके से रीड कर लेते हैं. It says when electron reaches a higher energy level, it is considered to be unstable. Therefore, it will eventually shift slash drop down into a lower energy level. And in doing so, it will emit electromagnetic radiations. Hence, this time around, we are going to get vertical lines with arrows pointing in the downward direction. बना के दिखा देता हूं, indicating de-excitation of an electron. I hope the term makes sense to you. and these lines are classified as examples of emission spectral lines. Okay, so you can simply remember them as follows: that an absorption spectral line is a vertical line with arrow pointing upwards, which results during the excitation of an electron. And an emission spectral line is a similar line with arrow pointing downwards, which arises during the de-excitation of an electron. Just in case अगर आपको draw करना हो, आप बहुत सारी emission spectral lines बना सकते हो. मैं बना के भी दिखा देता हूँ. Just a few of them. Randomly बना रहा हूँ. बस 2-3 बना देता हूँ. Just to imply that this is how emission spectral lines can be diagrammatically constructed. Sorry, Reha. I actually was confused between the pronunciation. मैं फिर भूल गया कि whether it was Adam or Adam. Anyways, खैर है. हाँ, डिस्ट्रैक्ट कर दिया तुमने मुझे यार. मैं क्या कह रहा था मैं भूल गया. Anyways, हाँ. So seriously, मैं भूल गया मैं क्या बोल रहा था. हाँ, I guess I was saying कि the emission spectral lines are going to be the vertical lines with arrows pointing in the downward direction. And these are going to be arising because of the de-excitation of an electron. Now, what's important for you to remember is that each of these lines, be it absorption spectral line or be it emission spectral line, each of this line corresponds to a unique wavelength or a unique frequency. The only difference is that in the previous case, the wavelength was getting absorbed by the incoming photon. Whereas in this case, as the name implies, emission spectral line, so this time around, the energy is going to be emitted. So look how the diagram differs slightly. So this time, the photon is going to be emitted. And in the previous case, the photon was kind of getting absorbed. So diagrammatically speaking, आप इस तरह से diagram की representation कर सकते हैं. So what's important for you to remember is that each of these spectral lines, and hence the name of the topic, spectral lines. So each of this spectral line corresponds to a unique wavelength or a unique frequency. In the first case, that wavelength slash frequency was getting absorbed due to the incoming photon. And in this case, a unique wavelength slash frequency is going to be emitted during the de-excitation of the electron. Now, one question जो वो बहुत दफा एग्जाम से पूछते हैं, उसके लिए मैंने एक नीचे वर्डिंग लिखी हुई है. तो पहले आप ये वर्डिंग रीड कर लो. और माय सजेशन टू यू वुड बी ये कंक्लूजन वाली वर्डिंग आई गेस लर्न कर लो तो ज्यादा सेंसिबल होगा. मैं भी साथ साथ रीड कर रहा हूँ, जरा स्टेटमेंट देख लेना. Since only certain wavelengths slash frequencies are getting absorbed slash emitted, therefore this provides evidence that electrons exist in fixed energy levels, or we can say that atoms have discrete energy levels. Hence, each atom slash element will have a unique or a discrete emission spectra slash absorption spectra. Say, ये wording important है for you to recognize and understand that since only certain wavelengths or frequencies are getting absorbed or emitted, therefore this provides evidence that electrons exist in fixed energy levels, or we can say atoms have discrete energy levels. Hence, each atom or each element will have a unique or a discrete emission spectral, or each atom slash element will have a unique emission spectra, or you can say it will have a unique absorption spectra. So atom to atom, these emission spectral lines or absorption spectral lines will differ. So every individual element will have its unique emission spectra slash absorption spectra. Now, one question, um, which they almost always inevitably ask, और वो usually 3 marks का होता है, but ये बहुत predominantly question आता है कि वो question की wordings ये देते हैं आपको, और generally मैंने हर question में जहाँ spectral line का question होता है ना, I've seen them asking this. So if this is the question that they ask you, so how would you approach the answer? So जरा question की wordings देख लो हाँ. So the question says, suggest why existence of spectral lines provides evidence for the existence of discrete energy levels in an atom. ठीक है, why existence of spectral line provides evidence for the existence of discrete energy levels in an atom. And generally this is of 3 marks. So your answer should be something along these lines. मेरा तो ख्याल है learn ही कर लीजिएगा. So first point, each spectral line correlates to a fixed energy change between any two energy levels. Second point, based on delta E is equal to hc upon lambda, comma, each energy change corresponds to a unique wavelength. And then the final statement, since only certain wavelengths are absorbed / emitted, therefore this indicates that atoms have discrete energy levels. सही? तो मैं quickly repeat कर दूं कि अब तक हम लोगों ने क्या चीजें discuss करी है. So we have seen the existence of absorption spectral lines, which arises due to electron excitation. Then we have seen the existence of emission spectral lines, which arises due to electron de-excitation. And thirdly, we have noticed that each spectral line corresponds to a unique wavelength, either getting absorbed or emitted. And the fact that only certain wavelengths are absorbed / emitted, this provides evidence that electrons exist in fixed energy levels, or you can say electrons exist in discrete energy levels. ठीक है guys, वापस रिपीट कर रहा हूँ, 3 पॉइंट्स पे ब्रेक डाउन करके बोल रहा हूँ. So the first point, absorption spectral lines arise due to electron excitation. Second point, emission spectral lines arise due to electron de-excitation. Third point, since each spectral line corresponds to a unique wavelength, therefore, this provides evidence for the fact that electrons in atoms exist in discrete energy levels. 4-5 लोग जरा ओके या अंडरस्टूड की वर्डिंग कर दीजिएगा, या इफ यू वांट मी टू रिपीट इट वंस अगेन तो दोबारा बता दीजिएगा ताकि फिर मैं आगे प्रोसीड करूं. ठीक है, सो फार सो गुड, सही है ना? ऑल राइट. तो यार ये वर्डिंग जो आपकी स्क्रीन पे नजर आ रही है ना, इसको प्लीज जरा प्रॉपर्ली लर्न कर लेना. मैं मेंशन कर भी देता हूँ, ये एग्जाम से बहुत दफा पूछ रहे होते हैं. ओके, नाउ वन अदर काइंड ऑफ क्वेश्चन जो नॉर्मली पूछा जाता है वो ये कि in the exams they'll give you the energy levels, E1, E2, E3, E4, and the question can just simply ask you, suggest the maximum possible number of emission spectral lines or absorption spectral lines, whatever, that can be formed due to electron transiting between the given energy levels. Okay, the question is asking you, what is the maximum possible number of emission spectral lines that can be formed due to electron transiting between the given energy levels? अब काफी लोग इसका आंसर लिटरली वो काउंट कर करके ऐसे करके बना देते हैं. सो देखिएगा, दिस इज वन वे ऑफ अप्रोचिंग इट कि आप सारे ऑप्शंस बना के दिखा दो. तो पहले मैं थोड़े से रेड कलर से बना के दिखा रहा हूँ. ऑल एरोज पॉइंटिंग इन द डाउनवर्ड डायरेक्शन. जस्ट अ फ्यू पॉसिबिलिटीज. ठीक है, ये सारे ट्रांजिशंस हो रहे हैं वेयर द इलेक्ट्रॉन इज ड्रॉपिंग डाउन फ्रॉम हायर एनर्जी लेवल्स डाउन टू E1. अच्छा, और भी हो सकते हैं. मुझे जहां जगह मिल रही है ना, मैं वहां बनाता जा रहा हूँ. सो कोई ऑर्डर ऑफ सीक्वेंस एज सच मैटर नहीं करता. ठीक है, सो रेड ones were all transitions dropping down to E1. Green represents all transitions dropping down to E2, or black represents transition dropping down to E3. अगर ड्रॉ करना हो ना, तो या तो ड्रॉ कर देना. सो टोटल आपके पास 6 ट्रांजिशंस आ रहे हैं ना. इसका मतलब है we can expect a total of 6 unique wavelengths, or you can say 6 unique frequencies that are going to be emitted if I were to take all the possible transitions into account. ठीक है, so I can expect a total of 6 unique wavelengths or 6 unique frequencies to be emitted if these transitions were to happen. अच्छा, दूसरा alternate ये है कि आप transitions को इस तरह से list कर दो. The red goes with red. The green goes with green. The black goes with black. ठीक है, सो इस तरह से सूट करे तो ऐसे लिख लेना. This also gives you a total of 6 transitions. So 6 unique wavelengths slash frequencies are going to be emitted if all the possible transitions were taken into account. अच्छा, और काफी लोग जिन्होंने स्टैट्स किया हुआ होता है ना, तो मैथ के अंदर जिन लोगों ने S1 किया हुआ है, they have done this topic of permutation and combination. So you can come up with the answer using the permutation and combination concept as well. So this is how. जिन्होंने किया हुआ है ना stats, maybe they can relate to this 4C2. तो direct answer आ जाएगा, then you don't need to essentially count it. Why 4C2? So 4 referring to the total number of energy levels, E1, E2, E3, E4, so 4 in total. And each line was connecting 2 energy levels, so 4C2. So 4 representing the total number of energy levels, and 2 because each line connects 2 of the energy levels. This is very similar to a question in stats if asked, here there is a total of 4 students available. There is a total of 4 students available, and you want to select a delegation of 2 students. In how many ways can this be done? तो मैथ्स में जिस तरह आप सोचते हैं ना, from a total of 4 students, you want to select a delegation of 2 students. तो used to go with 4C2. बिल्कुल वैसे ही Out of 4 energy levels available, each transition connects 2 energy levels, hence 4C2. जो भी वर्डिंग आपको सही लगे, तो मैंने इसके साथ ये स्टेटमेंट यहाँ पे लिख दिया है। मेरा ख्याल है ये स्टेटमेंट सेल्फ एक्सप्लेनेटरी है। आप रीड करोगे तो आप जस्टिफाई कर दोगे। So 6 unique wavelengths can be emitted if electron in this atom is allowed to perform all the possible transitions. ठीक है guys? So ये आपका आधे से ज्यादा टॉपिक तो इस पॉइंट पे कंप्लीट हो गया। मैं 5 मिनट्स की ब्रेक ले रहा हूँ और फिर रिमेनिंग थ्योरी का पोर्शन करा के इसको कंप्लीट कर देता हूँ। तब तक तुम लोग को होकर आना है तो होकर आ जाओ। मैं 5 मिनट्स के बाद कंटिन्यू कर रहा हूँ। तब तक मुझे कुछ इरेज करना हो ना तो आई जस्ट क्विकली लुक थ्रू फॉर दैट। अगर कुछ मिटाना होगा तो मैं इरेज आउट कर देता हूँ, अदरवाइज आई जस्ट लीव इट एज इट इज। आई विल बी बैक इन 5 मिनट्स, देन आई विल कंटिन्यू। ठीक है गाइस, 5 मिनट में आता हूँ एंड देन आई विल कंटिन्यू। तो थोड़ी सी थ्योरी रह गई है इस टॉपिक की, वो अभी आके करा देता हूँ। 5 मिनट में आ रहा हूँ। ठीक है, ऑलराइट। सब यार जो लास्ट चीज बच गई है ना इसकी डिस्कशन में, उसको देख लेते हैं। सो द वन क्वेश्चन दैट इज लेफ्ट अनआंसर्ड, ठीक है, और ये आई थिंक बहुत कॉमन क्वेश्चन है कि हाउ कैन वी experimentally decide which wavelengths are going to be absorbed slash emitted by a particular atom. And so I think this question does make sense. Ki, sir, how can we actually decide which specific wavelengths are going to be absorbed or emitted by a particular atom? So, as a general example, imagine करें कि if you are provided with a glass tube, a transparent glass tube, and let's suppose this glass tube is filled with some gas. The gas could be nitrogen gas or oxygen gas, whatever. So gas molecules are inside the glass tube. And imagine if you want to visually find out which specific wavelengths are going to be absorbed by this particular gas, then the easiest approach would be कि आप एक साइड से white light को incident करो on the glass tube. The reason I am saying कि आप white light को incident करो is because you all know white light is made out of 7 colors, ranging from violet all the way down to red. And you would possibly also remember from AS that white light has a range of wavelength ranging from 400 nanometers for violet, going all the way up to 700 nanometers for red. So आप एक range of wavelengths को, let's say white light, so violet all the way up through red, going from 400 nanometers to 700 nanometers. This is the first slide after break. Yes, Riha, I just started. ठीक है, so if we experimentally want to decide which wavelengths are going to be absorbed or emitted by a particular atom, तो बस आप ये करें कि ग्लास की ट्यूब को किसी भी मोनो एटॉमिक गैस से या डायटोमिक गैस से किसी भी गैस से फिल अप कर दें. द गैस मॉलिक्यूल्स आर शोन विद द रेड डॉट्स एंड अलाउ व्हाइट लाइट to be incident onto the glass tube from one side. White light इसलिए मैं specify कर रहा हूँ because it comprises of the entire range of spectrum, a continuous spectrum from violet going all the way up to red. So white light basically comprises of all wavelengths ranging from 400 nanometers up to let's say 700 nanometers. फिर आप बस इतना करो कि आप दूसरी वाली साइड के ऊपर एक स्क्रीन को प्लेस कर दो. अब मेरा ख्याल है आप खुद भी इस बात को अप्रिशिएट करोगे कि इफ आई आस्क यू कि व्हाट विल बी द अपीयरेंस ऑन द स्क्रीन, ये थोड़ा सा केयरफुली मेरी वर्डिंग्स को सुन लेना. सो आई थिंक यू कैन डिस्टिंक्टिवली कम अप विद टू आंसर्स. जो मैं लिख रहा हूं तो आप जरा पहले इसकी वर्डिंग्स को फॉलो कर लें कि व्हाट वुड द अपीयरेंस ऑन द स्क्रीन लुक लाइक. सो मेरा पहला स्टेटमेंट देखिएगा. दोज वेवलेंथ, पूरा लिख देता हूं, which will not cause any excitation will pass right through the tube and will reach the screen. Whereas the wavelengths which are going to be absorbed by the gas will not emerge out from the other side with full intensity. पूरी वर्डिंग देखिएगा. So my statement is suggesting that those specific wavelengths which are not capable of causing any excitation, so the gas will not absorb those wavelengths. So these wavelengths will pass right through the tube and will reach the screen on the other side. Whereas the wavelengths which are responsible to cause excitation, that is the wavelengths which are going to be absorbed by the gas, will not emerge out from the other side with full intensity. Hence, आपकी ऑब्जर्वेशन ये होगी कि स्क्रीन के ऊपर you will be able to distinctively see high intensity region and low intensity regions. Would you agree high intensity regions वो होंगे which will correspond to those wavelengths which were not able to cause any excitation. So the wavelengths which were able to pass right through without getting absorbed, they are the ones whose appearance on the screen will be that with high intensity, whereas low intensity refers to those particular wavelengths which were capable of causing excitation. Hence, those unique wavelengths were absorbed by the gas. Consequently, they were not able to pass through with full intensity. So, जरा दोबारा देखिएगा कि मैंने इस पूरे स्टेटमेंट्स के अंदर क्या-क्या चीजें लिखी हैं. So my question over here was कि how can we experimentally decide? How can we experimentally decide which wavelengths are going to be absorbed by a particular atom? So in order to achieve or find out which particular wavelengths are able to cause excitation or which particular wavelengths are going to be absorbed by a particular atom, uh, take a gas जिसको भी आपने demonstration के लिए use करना है, उसको glass tube से fill up कर दो and allow white light to fall from a certain one side and position a screen on the other side. Now, white light has a range of wavelengths going all the way from 400 down to 700. So allow all of these wavelengths to simultaneously strike the gas molecules inside the glass tube, and then look for my initial statement states regarding the appearance that those particular wavelengths which were not able to cause any excitation, they will pass right through the tube and they'll be able to strike the screen. फिर मैंने further आगे लिखा, whereas the wavelengths which are going to be absorbed, so the wavelengths which are responsible for causing excitation of the gas, will not emerge out from the other side with full intensity because some amount of those wavelengths is going to be absorbed by the gas, तो उनकी intensity reduce हो जाएगी. So on the basis of this, आपकी screen की observation ये होगी कि आपको screen पे certain regions के अंदर high intensity के patches नजर आएंगे. All colors which will appear with high intensity are going to correlate with the wavelengths which were unable to cause any excitation. Whereas all wavelengths which will correspond to low intensity patches are going to be the ones which were able to cause excitation, and hence those wavelengths got absorbed. सही है ना? अच्छा, एडम ने लिखा है इट्स लो बिकॉज दे weren't completely absorbed. So एडम उसका आंसर मेरे नेक्स्ट पेज पर आ जाएगा कि मैंने लो क्यों लिखा है. अच्छा, काफी लोग कहते हैं सर लो नहीं लिखें, और काफी लोग जिस तरह एडम ने सजेस्ट किया है ना, काफी लोग ये कहते हैं कि सर लो के बजाय द वर्डिंग शुड बी जीरो इंटेंसिटी, एंड आई डोंट माइंड दैट. है ना, जीरो लोगों को इसलिए साउंड अच्छा करता है because the term zero intensity kind of implies that the entire intensity was absorbed by the gas. तो यार मैंने लो किसी वजह से लिखा है, और लो शायद इसलिए लिखा है क्योंकि ऑल दो जीरो इशू नहीं है. तो अगर आपको जीरो इंटेंसिटी लिखना है विच इज परफेक्टली फाइन बाय मी, तो आप जीरो इंटेंसिटी भी लिख सकते हो, आप डार्क लाइंस भी लिख सकते हो, आप डार्क पैचेस भी लिख सकते हो, ये वर्डिंग बिल्कुल सही है ना. लेकिन मैंने लो प्रेफर इसलिए किया बिकॉज आई वॉज एक्सपेक्टिंग कि शायद आप रिकग्नाइज करोगे कि एब्जॉर्ब होना इज नॉट द एंड ऑफ इशू. एब्जॉर्ब होने के बाद रिमेंबर इमिट भी तो होना है, तो एब्जॉर्ब होने के बाद इमिट भी होना था ना. तो मैंने इसीलिए आई प्रेफर्ड यूजिंग द टर्म लो इंटेंसिटी, ताकि आपके दिमाग में दोनों चीजें रहे कि इनिशियली इट गेट्स एब्जॉर्ब्ड and then later on it might get emitted. Hence the term low intensity kind of makes more sense. But in all fairness, अगर आपको zero intensity बोलना है, dark lines बोलना है, simply because the colors are getting absorbed, so अगर आपको low intensity का term के बजाय zero intensity या dark lines कहना है, so exams में इस चीज का issue नहीं होता. But the only reason I prefer to use low intensity was because the colors are not just going to get absorbed, or the wavelengths are not just going to get absorbed. At some later stage, they might get emitted. Hence, I preferred using the term low intensity. So, Adam, पहले तुम जरा मुझे okay कर देना कि you are fine by the terminology usage. So low भी सही है, zero भी सही है. ठीक है, so अगर आप सिर्फ absorption को consider करते हो and that's about it, तो फिर आप zero intensity बोल दो, it's perfectly all right. लेकिन अगर आप absorption and then follow it up by emission दोनों को consider करते हो, तो फिर I think low intensity का term sounds slightly better. ठीक है, अब ये जो मैंने पूरी डेमोन्स्ट्रेशन यहाँ पे लिखी है ना, इस पूरी एक्सपेरिमेंट की, ये एग्जाम्स में ये एक्सपेरिमेंट पूरा का पूरा 5 to 6 मार्क्स का आता है. तो जिस तरह से मैंने लिखा है ना, ये तो बहुत फजूल तरीका है. इट इज एक्सपेक्टेड कि आप इसकी प्रॉपर टर्मिनोलॉजी को अप्रोप्रिएट फॉर्म में, एक्सपेरिमेंटल फॉर्म में लिखोगे. तो मैं अब स्लाइड को चेंज करता हूं. थिंक ऑफ दिस इज अ रफ वर्क जो मैंने एक्सप्लेन करने के लिए यूज किया है, एंड आई लेबल दिस एज स्लाइड 2. और जो एक्चुअल एग्जाम्स के अंदर जो एक्चुअल एक्सपेरिमेंट इफ दे आस्क यू फॉर 5 और 6 मार्क्स, तो जो आपको लिखना पड़ता है वो मैं आपको स्लाइड 3 पे शो करता हूं. पहले मैं हेडिंग डाल दूं, फिर मैं पूरा एक्सपेरिमेंट आपके साथ रिव्यू कर लेता हूं. ये भी लर्न कर लीजिएगा बिकॉज एग्जाम से बहुत फ्रीक्वेंटली ये पूरा एक्सपेरिमेंट लिखने के लिए आता है. एक्सपेरिमेंट टू डिटरमिन द एब्जॉर्प्शन स्पेक्ट्रम और एनी गैस. मैंने एग्जाम्पल के अंदर हाइड्रोजन गैस लिया है, इट कुड बी एनी गैस फॉर दैट मैटर. तो अब पहले पूरी वर्डिंग्स को देखिएगा, मेरे साथ साथ स्टेटमेंट्स फॉलो कर लो. तो आपको एक्सपेरिमेंटल ऑब्जर्वेशंस में क्या क्या डिटेल्स कितनी लिखनी है ना, वो आप यहां से देख लेना. मैं रीड करते जा रहा हूं, आप जरा देख लीजिएगा. The absorption spectrum of hydrogen, it doesn't have to be hydrogen, mind you, it could be any substance. मैंने सिंस डायग्राम पे हाइड्रोजन गैस लिखा है ना, तो मैंने उसके रेफरेंस से वर्डिंग्स लिखी है. The absorption spectrum of hydrogen is produced when white light passes through a tube filled with hydrogen gas. That is your figure 1. If the light that passed through the hydrogen gas is observed, comma, certain positions of the continuous spectrum of white light are observed to be dark lines. ठीक है, तो मैंने वो एडम की वर्डिंग को ड्यू इंपॉर्टेंस दी हुई है by using the term dark lines. This is the absorption spectrum of hydrogen. अब मैंने रीजनिंग लिखी है कि डार्क लाइंस क्यों अराइज करती हैं. The position of dark lines coincides exactly with the emission spectrum of hydrogen. The existence of these dark lines, ये important है, is due to photons of certain frequencies slash wavelengths in the incident light being absorbed. Wordings follow कर रहे हैं ना. Last 4 lines देखें. The existence of these dark lines is due to photons of certain frequencies slash wavelengths in the incident light being absorbed by the hydrogen atom. आगे देखें. The photons absorbed are those which have the same frequencies slash wavelengths whose energy corresponds to the energy difference between any two energy levels. है ना. Last 3 lines दोबारा read करें. The highlighted last 3 lines. The photons absorbed are those which have the same frequencies slash wavelengths whose energy corresponds to the energy difference between any two energy levels. है ना, जरा वर्डिंग्स को अपने दिल की आरजुओं को साइड पे रखिएगा और जैसे मैंने लिखा है ना, जरा वर्डिंग्स को इसी तरह से लर्न कीजिएगा. दिस इज द अप्रोप्रिएट वे ऑफ राइटिंग इट डाउन. दैट इज द एनर्जी ऑफ द इनकमिंग photon is absorbed to raise the electron to a higher energy level. When the excited electron returns to its original energy level, the difference in energy is radiated in all directions. Since the component of intensity of this emitted light in the original direction of incidence of the white light is only a small fraction of that emitted, comma, light of this wavelength has a lower intensity compared to those wavelengths which are not absorbed. तसल्ली से ये पूरी वर्डिंग इत्मीनान से रीड करें. एंड आई एम होपिंग कि आपकी अंग्रेजी इतनी है कि आप इसको रिलेट कर सकते हो. तो वो ब्रैकेट वाली वर्डिंग्स को प्लीज जरा प्रॉपर्ली रीड करो. मैं खामोश हो जाता हूं ताकि आप सही तरह रीड कर सको. हसन अभी आंसर दे रहा हूं तुम्हें क्वेश्चन का. रेड वाले ब्रैकेट की वर्डिंग्स को प्लीज प्रॉपर्ली रीड करो. मर्जिया आपके भी क्वेश्चन का भी आंसर दे रहा हूं. तो गाइस जरा मुझे ओके करते जाओगे कि आपने वो रेड वाली टर्मिनोलॉजी जिसके साथ मैंने ब्रैकेट ओपन और क्लोज किया है ना विद द रेड कलर, वो आपने रीड कर लिया है और आपने फॉलो कर लिया है कि मैंने वर्डिंग्स क्या लिखी हुई है. फिर मैं हसान को और मर्जिया को आंसर दे दूं. किसी को कोई वर्डिंग स्पेसिफिकली मुझे रिपीट करनी हो ना, तो आप अनम्यूट करके मुझसे पूछ लो, वरना मुझे ओके करते जाना. जी गाइस, आर यू विथ मी विद द हाइलाइटेड वर्डिंग्स विद द येलो मार्कर, ताकि मैं लास्ट की फ्यू लाइंस रीड कर दूं बिफोर आई कंक्लूड. ठीक है, जरा सारी वर्डिंग्स को इत्मीनान से अच्छे तरीके से रीड कर ले, तो द वर्डिंग शुड मेक सम सेंस टू यू. ये क्या लिखा हुआ है? एनर्जी रिफर्स टू लाइट. यस. अब फाइनल स्टेटमेंट पढ़ लो. Hence, the re-emitted light of definite wavelengths are only seen as either you can say dark lines or you can say low intensity lines against a continuous spectrum of white light. ठीक है, अब दो लोगों ने क्वेश्चंस पूछे हुए थे. सो नहीं मर्जिया, दिस कम्स इन P4. ठीक है, और जब भी आया P4 में आया और काफी फ्रीक्वेंटली आया, तो आई गेस यू बेटर लर्न दिस वर्डिंग. और दूसरी चीज, हसान ने पूछा हुआ था हाउ मेनी मार्क्स. यार 5 मार्क्स का भी मैंने देखा है, 6 मार्क्स का भी देखा है. तो समटाइम्स व्हेन दे एक्सपेक्ट यू टू ड्रॉ द डायग्राम, तो आई गेस फिर वो 6 मार्क्स का हो जाता है. बट समटाइम्स व्हेन दे ओनली एक्सपेक्ट यू टू राइट डाउन द एक्सप्लेनेशन, तो फिर वो डायग्राम का मार्क हटा के फिर 5 मार्क्स का कर देते हैं. सही. सो ये पूरा नोट, जिसको मैं थोड़ा सा जूम आउट कर रहा हूँ, जब टाइम मिले तो प्लीज इसकी वर्डिंग्स को लर्न कर लेना. यूजुअली डायग्राम्स मैंने देखा है नहीं मांगते हैं, बट एक्सप्लेनेशन का पार्ट डेफिनेटली मांगते हैं. तो कोशिश करना कि अपने ओन वर्ड्स में लिखने के बजाय जरा अप्रोप्रिएट फॉर्म में लिख दीजिएगा. तो टर्मिनोलॉजीज अगर हो सके तो याद कर लीजिएगा। और बस 1 सेकंड और मुझे दे दें। तो मैं हाइलाइटेड लाइन्स थोड़ी-सी और इरेज़ आउट कर दूँ। ठीक है, तो यार मैं इस वाले को स्लाइड 3 कर देता हूँ। ठीक है, तो मैंने आज वाली क्लास के अंदर वी हैव कंक्लूडेड द वर्किंग ऑफ स्पेक्ट्रल लाइन्स। मैंने स्लाइड 1, 2 और 3 करके किया था। लेट मी जस्ट क्विकली शो देम टू यू। सो दिस वाज़ द फर्स्ट वन, आपकी स्क्रीन पर आ जाएगी। ठीक है, so this was the starting under the heading energy levels and in brackets the spectral lines. So ये आपकी फर्स्ट वाली स्लाइड थी। This was just a rough representation as you would see in slide 2. So this was not as such required, लेकिन मैंने सिर्फ एक डायग्रामेटिक लेआउट की एक्सप्लेनेशन देने के लिए मैंने ये रफ वर्किंग करी थी। So this was slide 2 and the final format which is required to be learned as slide 3 के अंदर appropriate form में with the diagram and the explanation given है। ठीक है गाइस, तो आई कंक्लूड एट दिस पॉइंट। मैं लेक्चर अभी अपलोड कर देता हूँ, आप लोग इसको गो थ्रू कर लेना। फिर नेक्स्ट वाली क्लास के अंदर जो रिमेनिंग पोर्शन बच गया है ना, विच इज बैंड थ्योरी, दैट इज ऑल्सो वन क्लास लेक्चर। तो वो इंशाल्लाह नेक्स्ट वाली क्लास में कंक्लूड करा दूँ। ऑल राइट गाइस, सो थैंक यू, टेक केयर एंड खुदा हाफिज फॉर टुडे।